You have seen all those things, right? So we have just seen the symbols and all, and practically some of the components also we have seen, right? And we have also discussed about what is resistor. What is the function of a resistor? As I said, we know that even a small wire, conducting wire, if you take and if you just consider the or measure the resistance, we know that R equals to rho L by A, I said. What is rho? Resistivity. So particular material will have an resistivity based on whether it is an insulator, whether it's an conducting material or any metals, or it may be an insulators or semiconductors also. Depending upon the type of the material, each one will have a fixed resistivity. Resistivity is mentioned as a fixed number for each and every material, right? So L is nothing but an length of that particular conductor or insulator, whatever you are taken, material, length of the material. And A represents an area of cross section. So any shape, we know that it will have an area of cross section, right? So that gives you. Now according to this, what happens? R equals to rho L by A just defines that R is directly proportional to the length of the material and inversely proportional to the area of cross section of a material. Correct? So that means we can just say that as the length increases, resistance also increases. As the area of cross section increases, resistance will decrease. So vice versa. So that means whenever the length keeps on increasing, resistance keeps on increasing. If length is decreased, resistance also decreases. So coming to an area of cross section and relation with the resistance keeps on increasing as the area of cross section becomes lesser and lesser. That means we can just say that thin, as much as diameter is lesser for an wire, we can say that resistance will be more, right? So that is a difference you can see in an multi-strand wire, where why actually we use an multi-strand wire in any of the electrical conduction for an high voltage, high current and all. So one is skin effect. I'll just explain about the skin effect when we come across that. Other one is area of cross section. So basically we know that R equals to rho L by A. As I said, as the area of cross section is reduced, resistance will increase. So here multi-strand wire, what happens? The area of cross section of each strand is very less, right? Instead of that, if I use a solid wire, only one strand with a solid diameter will be high, area of cross section will be high, so resistance becomes lesser, isn't it? So therefore here you can just observe that this is why, that's the reason why we use a multi-strand wire. Another reason is skin effect. Skin effect will be lesser in a multi-strand wire. If you use a solid copper wire, instead of that, skin effect will be more. The leakage will be more. Skin effect leads to a leakage of current, right? So this is where actually we come across. So that is a function. Like this resistance, what is this resistance? As I said, we can measure the resistance. What is the meaning of a resistance? Resistance means it opposes the flow of current in a closed loop. We know all that flow of electrons in a closed loop is nothing but we say a current, right? So free electrons movement in a closed loop, or by applying an external source so that more and more free electrons will be released. That's why we apply a potential, right? What is the function of a potential? Potential will just make it just pulls the electrons out. Free electrons will become more and more, and it aligns. It aligns in a particular direction which have been scattered. Even in a very good conductor also, just like that, if you connect a wire, it will not conduct. Current flow agata? Illa. Why? It requires some driving force for these free electrons. Correct? Driving force should be there. Then only you can just observe that it aligns. So since if you connect an external potential, so we know that positive and negative terminal will be there. So this force will drive the electrons in a particular direction, where always we know that it gets attracted towards the positive terminal of the supply and moves in a circular pattern. So that is a function. That means as the resistance keeps increasing, the flow of current keeps decreasing. The amount of current will be controlled. Okay. Suppose if I have a source, if I have an conductor, if I apply both, or if I apply a driving force across the conductor, as the conductor resistance keeps increasing, the current flow keeps decreasing. As the resistance of the material is higher and higher, the current flow will keep on decreasing. So this monitors the current or resists the current or resists the flow of electric charges, or it resists a flow of electrons in a closed loop. Resist under monitors. That means it does not stop, it cannot stop, right? So it will control. As the value of the resistance keeps on increasing andre nagate, number of electrons which have been moving will keep on reducing. So as the number of electrons circulating will reduce, what happens? Amount of current will also reduces, because I is equal to dq by dt. Isn't it? Q by T we say. Number of charge carriers per time. So that gives you the current. Correct? So therefore here resistance plays a very important role in an electrical circuit. So without suppose you imagine that resistance was not found. Nobody knows about the resistance. What happens? We doesn't know how to control the current, right? We doesn't know what has been. So maybe we know that when we connect some driving force across the conductor, it will conduct. But if I wanted a particular amount of current to my circuits, I just wanted to drag only an particular amount, say about 1 amp. I have an 3 amps of current in a source. But I don't want 3 amps to my circuit. I want only an 2 amps or 1 amp. So what I'll do? I'll connect a resistor in such a way that design it, and I'll see that only 1 amp current will pass to my circuit or to my load. So those exercises will work on this. So what are all the different types of resistors? Based on a different applications, we can observe that there are so many different types of resistors. So suppose if you are using a very low current, then we use an normal carbon film or metal film resistors. That already you have seen, right? These resistors you have seen already. See, these are all the resistors what you have seen. You can just pass it on. So you can just see, go through and you can just check it. And if I wanted to use an higher current, I am talking about a low current and high current applications. So as I just go for an higher and higher current, wattage of the resistance should be higher. So previous class itself I just explained to you that we know that the power dissipation across the resistor will be in the form of an heat. How do you calculate the power? V into I. What is the voltage dropping across the resistor? And also what is the current that is flowing through the resistor? V into I gives you what is called as an power. Right. Suppose if there is an, as I said, 1 milliamp current is passing through the resistor or through the conductor, whatever it may be, and voltage drop will be equal to about 2 volts. 2 volts into 1 milliamp, how much is that? 2 into 1, it is 2 milliamps. Milliwatts. 2 milliwatts. So 2 milliwatts is 2 less. So that means it is less than an quarter watt. Correct? Isn't it? So then I can use that quarter watt resistor, whatever I just given to you. Now let me say that the circuit is in such a way that I just wanted a circuit to be with an current should be drawn with an 1 ampere. So previously I said 1 milliamp. Now 1 amp current is passing and the resistor whatever I connected, the voltage drop is same as 1 volt anta itಕೊಳ್ಳಿ. Okay, 1 volt drop is there. 1 volt into 1 ampere, it is nothing but an 1 watt of power dissipation. So that means it is dissipating a power of 1 watt. Can I use quarter watt resistor here? Because the quarter watt resistor can withstand, or it can withstand the temperature of quarter watt only. Andre 0.25 watts of power only, not more than that, right? Now it is totally dropping up and about an 1 watt of power. So 1 watt power, if it has to withstand, that temperature it has to withstand, means I should use an more than 1 watt rating of resistor. You can just observe that. See, these are all the resistors where we can see it is an 1 watt resistor. Check this. You can observe the size difference. As the wattage increases, I told you that sizes will also increases. So, still coming to this is a wire wound, okay, wire wound resistor. So, wattage here is 5 watts. And how do you check it? I'll tell you how the wattage will be checked. So normally in wire wound and all, they will write it on the resistor itself. You can just check it. Tell me that what is the wattage written on that? Pass it and just pass back once again to the front. Resistor covers, you just pass it. What is the wattage it has been written?
5 watt.
5 watts. 5 watts resistor. 4 watts, 5 watts. So check ಮಾಡಿ. 5 watts. Now suppose the total power dissipating across the resistor is, let me say 4 watts. Can I use 1 watt resistor there in that place? Value of the resistor may be same, isn't it? Value of the resistor is nothing to do with, because I just wanted to use 1K resistor for the voltage drop of 1 volt, right? 1K only I may use, but wattage is not at all 1 watt. It is required 1K with an 4 watts. That's what I just explained in the last class. See, resistance value is not at all connected with an wattage. Same resistor value may be there, but how much current actually it is flowing, that is very, very important. Based on that, I'll decide that what should be the wattage of resistor that I should use in the circuit. Okay. So this is what, instead of that, if I use lesser wattage resistor, it will get burnt. Circuit will become open circuit. So suppose if I design a power supply, there where the power supply total current rating is 2 amperes, I design everything. Instead of 2 amperes, say 2 amperes is the current, maximum current that has been designed to flow in the circuit, or it is giving an 0 to 30 volts, 2 amperes of current. So that means across the load we are getting that much of current. So in the load resistor, if I connect a wattage of say about 1 watt, where the current can withstand is only 1 ampere. If I just connect it like that, it will get burned. So that means the prototype of that whatever I design, it will be a waste, isn't it? So therefore what we do normally, we just look into a prototype circuit, we simulate and we just check it, we decide it, we design and we see that what should be the wattage rating maximum, and beyond that we should always use an higher value of wattage there. Okay. So this is a must actually. So now I'll also give you a group of resistors of same 1K. You need to measure each and every resistor with the multimeter. Color code will say same, right? Tolerance will also be same. But if you measure it with the multimeter, the values will be different. Same values. Okay. Then you tell me, you comment on that and analyze and tell me that why it is so. So that is one of the exercises after this color coding. Look into this, how to just tell about what is the resistance value. How do you come to know? See, some of the resistors it has been written. So for an higher wattage of resistor, it has been written. Wire one you have seen. Other two, whatever I just passed, that is quarter watt, keep this side. Quarter watt resistors and also an half watt resistor or 1 watt resistors. One more pack. Yeah. So this is quarter watt, 1 watt, and also we have an 5 watt resistor. Right. So when you just look into the small wattage resistors, quarter watt and 1 watt, can you just see, is it written on that? No. Then how do you find out? Based on the size. So standard size has been maintained for quarter watt and also for half watt, 1 watt, like that. So that size is also you can just look into specification sheet. They'll give a clear size of that resistor when it is an half watt, what is the size? Quarter watt, what is the size? So these are all standardized, not only in India, throughout the world. This is standardized. IEEE standards will be maintained here. So otherwise, if I use something, some other country uses something, it's not like that. So IEEE has got a standard coding, standard color code, standard sizes for all the resistors, capacitors, all components. Okay. Now coming to this, lower values, as I said, it is not written. Okay. Even the value is also not written. If you just keep on go for higher values, it has been written what is the value of the resistor. 10K, 1K, 100 ohms and all you can just see on this. So now what is the value? 5 watt. What is the value of resistance? Didn't check that? Should observe both the things. You want to open? Read the value on that. It's written, clearly written. No? Get it? And top it has written. Can anybody read that value? 4 watts ಕೆಳಗಡೆ ಇದೆ. So top it has been written. Just read it out. What is the value? It is written. Top of that?
It is something KVU. It is looking like KVU.
Okay. ಪಕ್ಕದಲ್ಲಿ ನೋಡಿಲ್ಲ. Just see there. 5 watt pakka. What is that it has written? 0K5 anta. Can you just see that? Multimeter ತಗೊಂಡಿದ್ದೀರಾ ನಿಮ್ದು? You're not taken. $500 ohms. This is an 500 ohms resistor. Okay. So 0K5 ಅಂತಿದೆ ಅಲ್ಲಿ. ಅಂದ್ರೆ 0.5 K. 0.5 K ಅಂದ್ರೆ it is nothing but a right. So this is how actually, but other resistors you have seen that it's not written anything, right? Value is not written on that. How to measure it? By color code. Looking into the color code, we can just measure what is the resistance value. Okay. So this is how we can just look into that. Each one of you just have one resistor in that quarter watt, full watt, 1 watt only. ನಿಮ್ಮ ಹತ್ರ ಇದೆಯಾ ಅದು? Yeah. Please check this. Open ಮಾಡ್ಬಿಟ್ಟು ಒಬ್ರು ಒಂದೊಂದು ಬರುತ್ತೆ ತೊಗೊಳ್ಳಿ. Just have it. Pass it on. so that you will come to know how to measure it. Okay, now let us just go to this. You can observe the color code. What are all the bands you can see? One side you have three different colors. Check it. Sometimes four also. Check that. Can you see? ಅಲ್ಲ continuous three bands ಇದೆ ನೋಡಿ. And other side you'll be so we have 4 band resistor, 5 band color resistor, 6 band, all three are there. So which is your color code band? 4 in that. So you have an 4. Some of you has got 5. Okay, you can exchange afterwards, you can exchange and check it. See, so in 4 band resistor, so this gives you the value 3 colors, and the last one gives you what is the tolerance. Okay, and here also you can just observe here. You can observe here. See, continuous 3 or 4 band is there. That is, first digit is nothing but as it is you have to write down. Okay, first one represents about a number you have to write down. Second one also it represents the digit. Third one will be an digit in case of an 4 band. Okay, continuous 4 band. Fourth one will be multiplier. So coming to this first one, you can just observe. See here, color code will be either black to an up to white. Starting colors ಏನಿದೆಯಲ್ಲ, you can just observe. Continuous 3 band colors ಇದೆಯಲ್ಲ, either of one will be there. Black, brown, red, orange, yellow, green, blue, violet, grey, white. This is the order. How do you remember? Some of you remember with an B.B. Rai had a great. Yes? Okay. Why? So you just use whatever coding you want. So normally we used to use it as black boy had an black boy runs over young girl, but Veena gets wild. This is what we used to use. Black boy runs over young girl, but Veena gets wild. So this is the color coding what we used to use it. See, it depends. It depends. Whatever the coding you learn, you can use the same coding. So this is the code what we used to use it. So that means black boy runs over young girl, but Veena gets wild. So black is for black only. The digit for black is 0. So next one I said black boy. We just code is black boy. Next code is brown. B is boy means first letter is brown. So here the digit value is 1. Black boy runs. First letter is R. Red. So the digit value is 2. Next, runs over. Over first letter is orange. So that is value is 3. Okay. Runs over. Black boy runs over young girl. So yeah, Y is yellow. It is 4 digit. The value of this is 4. The color green runs over young girl. G is the first letter. So for that it is 5. And blue is 6. Young girl, but B is but that is blue. It is value is 6. But Veena, so V is violet, but Veena gets wild. So G for gray, so it is 8. And next is wild, it is white, W for white, so that is 9. So like that, the color coding for an this starting from black to white we have. So you can just see that black with 0, brown with 1, red with 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, white will be 9. So this is the first band what you can see. A set of band you will have, either it may be 3 or it may be 4. Correct? Look into this. If there are 4, suppose if there are 4, then 1, 2, 3 as it is, whatever the color code value is there, you have to write down. That is a digit value. Last band is for multiplier. That 10 rise to that value. For example, you just look into this. We have here 4 band. 4 band means 3 are continuous value code, resistor value code, and last one is for tolerance. I'll explain about the tolerance afterwards. First, we'll learn about how to find out the value of a resistor, that's all. See here, brown, black, brown. What is the value of brown? 1. Right? According to this. So you can write down in the side if you want. So you can put whatever the code you can remember, you can put it. So once you just keep on using that, you'll use to that. So if I just ask me now any color, I can just tell you what is the value of that. That is, we are using it frequently. If you use it, definitely you will come to know what is the value. Okay. So now here brown is there 1, black value is 0. Again brown is there. Since it is only 3 color bands, first and second I use it as a digit. So that is 1, 0 multiplied by third one is an multiplier. So that means 10 to the power of 1. 10 to the power of 1. 1 0 into 10 to the power of 1 is 100. Got it now? So similarly, come to the second one. See, we have next is an 5 band resistor. This is. So 4 bands represent the value of the resistor. Last one is for tolerance. Okay. So now coming to this one is brown. Again the value of brown is 1. Next we have violet. What is the color code violet represent? 7. So 1, 7. Next band is black 0. Correct? So how much is that? 170 multiplied by 10 to the power of, what is the violet value? 7. 7. 10 to the power of 7. Just calculate. How much is that? 170 into 10 to the power of 7. And how do you represent the resistor values? Ohms. Okay. Ohms is the unit of resistance. Normally resistances are represented in just ohms. If it is in kilo ohms, it is into 10 to the power of 3. Okay. So suppose 100 into 10 to the power of 3 means 100 kilo ohms. Correct? And next higher value is mega ohms. That is 10 to the power of 6. 100 into 10 to the power of 6 means
1700 mega.
Mega. 10 to the power of 6 represents a mega. Then, which is higher value? Giga. Okay. So that is 10 to the power of 9. Okay. Like this it keeps on increasing. So normally in the resistors we are going to use it in an kilo ohms or in an mega ohms. Normally. So 1000 mega ohms, 10,000 mega ohms, like that we will just represent. Here we have the value is 170 into 10 to the power of 7. Correct? So that means 1700 into 10 to the power of 6 we can make. So that is nothing but 1700 mega ohms. Got it? Write down the value. So that means 170 into 10 to the power of 7. I can just make it into a represent it in the form of an mega ohms. So therefore what I will do? One of the multiplier 0 I will take it to the other side. 1700 into 10 to the power of 6 I can represent. So that is nothing but 1700 mega ohms. Correct? Coming to the other one. You just see one more resistor band, you can see 6 band resistor here. 6-band resistor, what are all the colors you have? Green, violet, black, yellow. Okay. So green represents 5, correct? Green represents 5. Here also once again, so first digits whatever it is there, you have to consider it for a value. Just write down the value of the color code. The last one represent the multiplier. Okay. And other side of the resistor, whatever it is there, we represent it with an what is called as an tolerance and also temperature coefficient, parts per minute or part per millimeter. That's what ppm per k kelvins. Okay. So this is what we just represent. I'll tell you about that. So those things and all we use it in an R&D purposes and all, where we just want a very precision value of a resistor. For example, precision andre, I just want 100 ohms. 100 ohms, I just wanted either the value changes maybe about 99.5 or 100.5. That's a tolerance I wanted. Not more than that, R&D purposes and all. So there I use that. What is the temperature coefficient? And temperature coefficient represents what will be the change in temperature for every 1 degree change in the temperature. What is the value of the resistor? It changes. So we know that coming to this resistors, so materials used, whatever materials we have used, we can observe that whenever there is a change in temperature, there will be a value changes. What is that value that changes with the temperature? That is represented by what is called as a temperature coefficient. So not that every resistor will have this temperature coefficient color code. So only, as I said, very precise resistors will have this ppms. Okay. So now coming to this fourth resistor, as I said, 6-band resistor. Green, we know that it is equivalent to value is 5. Violet is 7 once again, 5, 7. Black is 0, correct? 5, 7, 0. And last one is multiplier, 10 to the power of 4. Yellow is 4. Got it? So 570 into 10 to the power of 4. How to represent this? 570 into 10 to the power of 4. Can I just take it into mega? Yes. 5.7 mega ohms. Correct? I'll just take one of the zeros to the multiplier side. I'll represent 2 zeros. 570 is there now. 5.70 into 10 to the power of 6 I'll make it. It is equivalent to 5.7 mega ohms. Correct? Huh? So this is how we represent. Color coding you came to know. This is the whatever coding or symbols you wanted to use it, you can use it. So this is very easy. As soon as you look into that, you will come to know what is the value. Keep on using that. Okay. Because multimeters you may not be having all the time. So therefore, it's always very important that you should know the resistor value by color code. Got it now? Now coming to the last band. This is nothing but an tolerance. If only one band has been given, it is for tolerance. So look into this. Both the bands here, first resistor, 4-band resistor and 5-band resistor, you can see that yellow has been given, right? What is the value of yellow? Yellow or orange other? Gold. Sorry, gold. See, normally tolerance will be given as an gold color or silver color. Look into your resistors. What is the this one given?
Gold color.
Others? Tolerance kotilva. Color code kotirtar nodi. How many colors has been represented here?
5.
5 bands ide. 3 bands first ide. Or 4 bands idya first. 4 bands ide. 4 bands you know, I just explained. Last one separate agidya one band.
Brown color.
Kodin. Yes. Yeah, correct. Idu hige. You can observe the gap appa. See, 3 color code bands enide hatratra ide. Nearby. The last one is little bit far away. That is separated. since the resistor is very small, so you can make out the difference, right? ಇದು ಗೋಲ್ಡ್ ಯು ಕ್ಯಾನ್ ಸಿ ವೆರಿ ಕ್ಲಿಯರ್ಲಿ ನೋ ಸಿ ಫಸ್ಟ್ ಕಲರ್ಸ್ ಇಲ್ಲಿ ಮೂರಿದೆ ಲಾಸ್ಟ್ ಒನ್ ಇಸ್ ಗೋಲ್ಡ್ ಕಲರ್ ಯೆಲ್ಲೋ ವೈಲೆಟ್ ಇದು yellow violet orange yellow is 4 violet is 7 orange is 3 4 7 into 10 to the power of 3 last band is gold. Is there any doubts? ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ ನಿಮ್ಗೆ ಲಾಸ್ಟ್ ಬ್ಯಾಂಡ್ ಏನಿದೆ ನಿಮ್ದ್ರಲ್ಲಿ ಎಸ್ ಎಸ್ ಕರೆಕ್ಟ್ ಬ್ರೌನ್ ಇದೆ sometimes they will give the color also, that's what I'll going to explain. Normally tolerance band ಏನಿರುತ್ತೆ silver or gold ಇರುತ್ತೆ. Okay, see here silver or gold idre, if the last tolerance band is given mentioned as an gold, the tolerance is plus or minus 5% anta artha. If it is silver, it is plus or minus 10%. What is that 5%, 10% ಅಂದ್ರೆ ಅರ್ಥ ಏನು? Suppose, let me say, ನಿಮ್ದು ವ್ಯಾಲ್ಯೂಸ್ ಎಲ್ಲ ಬರ್ಕೊಳ್ಳಿ ನಿಮ್ಮ ಇದರಲ್ಲಿ. How many of you have got a gold color? Gold. Okay. Silver ಯಾರಿಗೆ ಬಂದಿದೆ? ಯಾರಿಗೂ ಇಲ್ಲ. Okay, gold color ಬಂದಿದೆ. So gold color, what is the tolerance? Plus or minus 5. See, that's what you just observe very clearly. Plus or minus 5 andre, write down the value. What is the 5% of that value you calculate? For example, 100 ohms ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. 100 ohmsಗೆ plus or minus 5 ಏನು? Plus or minus 5% ಏನು? No. I am asking what is the 5% of 100 ohms? 5 ohms. Correct? So that means the meaning here is the value of the resistor manufacturer has represented it as 100 ohms and it has got a tolerance of plus or minus 5 ohms anta artha. Andre the value of the resistor may be between 95 ohms to 105 ohms. That is the meaning. And others, ಬೇರೆಯವ್ರದ್ದು ಏನಿದೆ ನಿಮ್ದು ವ್ಯಾಲ್ಯೂ ಏನಿದೆ? What is the value of your resistor?
56 ohms.
56 ohms. What is the tolerance? Gold alla? Okay. 56 ohms ge what is the tolerance by the 5%? 5% of 56. Calculate 5% of 56. ನಿಮ್ resistor ನೀವು calculate ಮಾಡ್ಬೇಕು ಈಗ. Because I don't know what value you have got. What is the color code?
56 ohms.
56 ohms. 8.5% appa. It will not come. 56 ohms ge 5% calculate ಮಾಡಿ. 56 into multiply by 0.05. Yes, 2.8 ohms ಬರುತ್ತೆ. 2.8 ohms is the 5% of your 56 ohms. Correct? So that means what should be the value of your resistor when you measure? See, color code is giving it as 56. Tolerance has also mentioned it as 5%. So 56 plus or minus 2.8 ohms. Okay? So that means it may be less 2.8 or more 2.8 of 56. Got it now? Similarly, all your resistors are. Okay, now let me say that the resistance 5 and 10% we may not use it. Tolerance of 5% and 10% may not be required. So somewhere I require the very high precise resistors where the precision should be less than that. Nanige astu beda 5% to 10% alla nanige beda, because none values ge it should not range 5%, 10% low or high. I don't want. Then so resistors, while manufacturing itself, see there are techniques to manufacture the resistor where some of them or some manufacturing will be precise manufacturing. This will be like normal resistors what we use it in our labs and all. Look into this color code. Suppose if the tolerance band is black, sorry, brown. If the tolerance band is brown, the meaning of that is the tolerance is plus or minus 1% anta. What is the value of your resistors? What you have taken?
It's 47K.
47K. So what is the tolerance band?
Gold. Wait, ma'am. First of plus or
Gold.
minus 5%.
Okay, plus or minus 5%. 47K. What is the 5% of 47K?
300.
Yes. Okay. So plus or minus 2700 ohms. 300 ohms or 700, 350 ohms. So that is the meaning. Others, what you got? Color band brown arrow, the tolerance band brown arrow, the value? What is the value of your resistor?
100
Hmm.
10 to the power of 20. Third band.
3 codes only. 100. The last band is 4 bands idya.
5 bands ಒಳಗಡೆ ಲಾಸ್ಟ್ ಬ್ರೌನ್ ಕಲರ್ ಟಾಲರೆನ್ಸ್
5 bands idya nimdo. What are the 3 bands? First 3 bands?
ಫಸ್ಟ್ ಬ್ರೌನ್ ಬ್ಲಾಕ್ ಗ್ರೀನ್ ಲಾಸ್ಟ್ ಬ್ರೌನ್
Okay. So this is brown, black, green.
ಎಸ್ ಮ್ಯಾಮ್
So 100, green is 10 to the power of 5. Okay. 100 into 10 to the power of 5. Make it as mega. 100, 10 mega ohms. Okay. Into 10 to the power of 6, it is 10 mega ohms. So that is the value of your resistor. What is the tolerance? Brown color. Brown color tolerance value is plus or minus, says listen here, plus or minus 1%. So what is the 1% of 10 mega? 1% of 10 mega. 10 into 10 to the power of 6. 10 into 10 mega, isn't it? 10 into 10 to the power of 6 ohms. What is 1% of it? 1% calculate ಮಾಡಿಪಾ. Just take out your calculators. 10 kilo ohms. Got it? Got it? See, 10 mega ohms ಅಲ್ಲಿ plus or minus 10 kilo ohms difference ಇರುತ್ತೆ ಅಂತ ಅರ್ಥ. ಅಂದ್ರೆ it may be 9.9 mega ohms or it may be 10.1 mega ohms. ಅರ್ಥ ಆಯ್ತಾ ಈಗ? Correct? Isn't it? So that is the tolerance of your resistor anta. So that means it is precised. See, 5%, 10% is huge tolerance, right? So instead of that, it is given as an brown color where the tolerance is plus or minus 1%. Suppose if they give, go to the other colors. These are all the color bands for tolerance. Only these colors have been given. See, if it is and red, plus or minus 2, same value say, brown gain value 1. Brown idre plus or minus 1. Red idre plus or minus 2. So normally itrane irutte. Other than brown and red, we may have green, we may have blue, violet and also green. So if that is the case andre, if it is green, it is plus or minus 0.5%, still precise. Okay. So suppose 100 ohms andre, what is the 0.5% equal to? 100 ohms again. 0.5 ಅಷ್ಟೇ 0.5 ohms ಅಂದ್ರೆ ಏನರ್ಥ 99.95 or it may be 100.05. Correct? 0.5 andre that should be the difference. Andre you can imagine what is the precise value of resistor, you can get it even though the tolerance has been given. See, why this actually difference? You may be thinking that why this different values of resistors you will get it, right? Manufacturer alla ottige ಮಾಡ್ತಾರಲ್ಲ, why you are getting so many different values? Same batch if you take it also, this tolerance is applied. Why the tolerance is? You may just look into the resistors. The resistor size is so small, whatever the material they are using, it may be metal film, it may be carbon film, whatever it may be, ಆ ಫಿಲ್ಮ್ ಎಷ್ಟು ನೀವು ಆ ಮೆಟೀರಿಯಲ್ ಕಾಂಪೋಸಿಷನ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ ರೆಸಿಸ್ಟರ್ಗೆ, that cannot be controlled so much, isn't it? Even one small particle ppm of this adds up to that resistor extra andre, it will go higher value. One part ppm will just reduce that antandre, then again it will reduces the resistor. That is why same batch of resistor manufacturer adrunu, you will get this different values. So manufacturer agit kudle, if you take a bunch thousands of resistors togondre, that will maintain that tolerance. That's why the manufacturer will mention a tolerance value. Okay. So this is how same batch manufacturer adrunu values will be within that range irutte. That is because even a small minute nanoparticle onchur add up adre extra ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಒಂದು ನ್ಯಾನೋ ಪಾರ್ಟಿಕಲ್ ಕಡಿಮೆ ಆದರೆ ಕಡಿಮೆ ಆಗುತ್ತೆ ವ್ಯಾಲ್ಯೂ. ದಿಸ್ ಇಸ್ ಹೌ ಇಟ್ ಹ್ಯಾಸ್ ಬೀನ್ ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್. ಸೊ ದಟ್ ಈಸ್ ವೈ. ಆ್ಯಂಡ್ ಕಮಿಂಗ್ ಟು ದಿಸ್ 0.05 ನೋಡಿದ್ರಿ, ಸಾರಿ 0.5 ನೋಡಿದ್ರಿ ಗ್ರೀನ್ಗೆ, ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಸಿ ಫಾರ್ blue it is 0.25 and always it is represented as plus or minus. Either it should be in the higher or it may be in the lower side. And coming to an violet, it is plus or minus 0.1, still reduced, right? Still it is reduced, 0.25 in the 0.1, and if it is gray, plus or minus 0.05 as to. You can just see. So like that you can just see. And anyway we know that for gold it is plus or minus 5 and silver it is plus or minus 10. Normally silver ella ordinary cases where we can just see even if it is plus or minus 10 also it's okay. The value can be used. And value as the precision keeps on increasing, tolerance keeps on decreasing, the value of or the cost of the resistor will also be higher because manufacturing process will differ there. So therefore we can observe that resistor cost also depends upon what is the wattage, what is the tolerance of the resistor, and what type of resistor. So coming to the types, once again I just told you on that day itself, trimmer type ide where we can just use the screw and we can adjust the resistor. This resistor value it may be between an 0 to 10 kilo ohms. 0 in the 10 kilo ohms tanka you can screw ಮಾಡಿ adjust ಮಾಡಬಹುದು. Therefore they will give a 3 terminals resistor ge. So one is an variable terminal, 2 are fixed terminals. Okay, when you use it in the circuit you will come to know. And these are all the things. Same way you can also see the trimmers. Okay, trimmers all 3 legs irutte, you can just see that fix ಮಾಡ್ತಾರೆ. Same way central leg will just represent it as a variable resistor, other 2 legs will be a fixed resistor value. So ಎರಡು ಆ ಕಡೆ ಕೊಡೋದು end to end connect ಮಾಡಿದ್ರೆ 2 terminals ತಗೊಂಡ್ರೆ it acts as a fixed resistor. ಒಂದು end ಇನ್ನೊಂದು center ತಗೊಂಡ್ರೆ you can vary it, ಟ್ಯೂನ್ ಮಾಡಿ ವೇರಿ ಮಾಡಿದ್ರೆ 0 ಇಂದ ಅದು ಏನು ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೆ ಅಲ್ಲಿ ತನಕ it will vary. So you can just see that value of that resistors and all, you can just check it on the body of the resistor itself where it has been, legend printing will be given on that. Okay. So this is about the resistors. Now let us see that what is the application, how actually it behaves when we just go through this. ಯಾವ ಥರ ಬಿಹೇವ್ ಮಾಡುತ್ತೆ. So first we'll go to an resistors when they're connected in series, how does it behaves? You must be knowing, isn't it? Resistors when we connect it in the series, it will get added up. ಗೊತ್ತಿದೆ ಅಲ್ವಾ ಎಲ್ರಿಗೂ ಇದು? Suppose R1, R2, R3. What do you mean by series connection ಅಂದ್ರೆ ಏನು?
Same current.
Okay, technically. Then?
Components are connected to one.
Components are connected. Practically ಹೇಗೆ ಹೇಳ್ತಾರೆ? Now resistors connected in series. How do you just say that resistors are connected in series? One technical term what you are used is same current. When the same current flows through all the resistors, that is we say that resistors are connected in series anta. So when actually the current flows. Now let me say that we have resistor R1. So now look into this resistor R1. Let me see. Okay, one resistor is there. So another resistor, let me take it as R2. One more resistor I have R3. So here physically when I connecting, one end is connected to the other end. See here. So let me say this is front end, back end anta. So either back end or front connect ಮಾಡಿದೆ. And either the back end or I am connecting it to front end. Now resistors R1, R2, R3 are connected in series. If that is the case, you need to give me what is the equivalent value. Correct? Now, let me just go for a parallel connection. So same three resistors I'll take. Now I'll just take three resistors again. R1, I have R2, and I have R3. R2, R3. Now look into this. One common end andre all front end anta ತಗೊಂಡ್ವಿ ಅಲ್ವಾ front and back end ಅಂತ ತಗೊಂಡ್ವಿ. Let me say this is front back, front back, front back. Now all common ends connected together. So always you should put a connection andre dot ಅಲ್ಲಿ junction dark point ತೋರಿಸ್ಬೇಕು. So if it is a jumper, so that you should learn always. See now this point is there. I just connect like this and this is not connected. See suppose here let me say I have 0 volts ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. This point. It has been connected like this andre. So it does not mean that this point and this point has been joined together anta. If I put a dot here, then it says that junction point adu. So then it is connected. So sometimes otherwise to clarify, we can see that they'll put a jumper. See this is one connection andre. This jumper shows that these two lines are not connected anta. So connected anta ತೋರಿಸಬೇಕಾದ್ರೆ we should put a dot. Junction point has to be mentioned if it is connected. Got it now? So this is how these things is, you should be very careful when you are making the student to learn also in a circuit or any of the connections, wiring or whatever it may be. These points are very, very important. So when it is not connected andre, so the jumper or I can say that junction point will not be mentioned or jumper ide antare it's not connected. Whenever there is an point when you write the circuits also, whenever you just mention with the junction point, that means it is shorted together anta artha. So now come to this. I just said that all three common lines has been connected together and other three common lines I am just shorting. Sorry. I am just shorting together. These lines I have been shorted. Okay. So now across that, I just wanted to find out what is the equivalent resistor across this combination. How do you find out? Yes. 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So you have to find out like this. If there are two resistors, easily you can say R equivalent is equal to, for two resistors, easily we can say R equivalent is equal to, directly you can write down R1, R2 divided by R1 plus R2. For this anyway we need to calculate this. R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Is it clear here? Because many of you, when I just give any problem, saying that you cannot solve, because all those things basics you have just learned somehow and you just left it off. This is an equivalent resistor. Now let me give some combinations. You need to tell what is the equivalent resistance. Okay. So I'll give both parallel and series combination. Let me see that how many will understand that, and write down this problem. What is the equivalent resistance? This one you have to connect it on the breadboard and you have to prove that. How do you just find out the equivalent resistance?
So we need to know the value of.
Yeah, value let it be there. General things if you know, Andra, how to calculate if you know, you can find out for any resistor value, right? How do you find out if this is the case? Equivalent, I am just finding across the terminals AB, correct? Across the terminals AB. Looking into the terminals AB, I just wanted to find out what is the equivalent resistance. Hege hogtira? Start from this point. Now I just see that the current is flowing through an R3 first anta toltini. I'll just check it from looking into the terminals AB, because I wanted a equivalent resistance across the terminals AB. First I'll start from A. Okay. If I start from A, this is a junction, right? Correct? Ivella junctions. These are all nothing but junctions. At this junction, junction 1, how many divisions are there current if I take it? Correct? Correct? Two junction and 2 divide ಆಗ್ತಿದೆ. That means at junctions you can see that 2 branches are there. 2 branches means what? Resistors are connected in parallel anta. Correct? Branches andre, so previously we have just seen that. See, this is how. See, series ಅಲ್ಲಿ ಇದ್ದಾಗ ಏನಾಯ್ತು? How many branches were there? Throughout ಒಂದೇನಾ? Is there any division of branches there? Same branch it is flowing, only one branch. Parallel connect ಮಾಡಿದಾಗ ಏನಾಯ್ತು? When we connected in parallel, what happened? 3 resistors same ನಾನು connected in parallel ಮಾಡಿದಾಗ R1, R2, R3. And if I just look into this, see? So at this one you can observe that idu one branch ಆಯ್ತು. Correct? 2 branches divided at this junction, first junction ಅಲ್ಲಿ. Second branch ಅಲ್ಲಿ again what happened? 2 branches. ಹೌದಾ? So this is same anyway, we don't have any junction. So either two branches ಆಯ್ತು. ಅಂದ್ರೆ you can observe that when I just look into that, at first junction I had R2 and R3 are in parallel. Okay. Again ಇಲ್ಲಿಗೆ ಬಂದಾಗ ಏನಾಯ್ತು, these two are there. So like that there are three branches totally. These are all common point. If I take this as a common point, I can write down this also like this. See here, R1, R2, common point than other. And all these points I can just write down like this, correct? Isn't it? Now, these are the equivalent resistance and I'll find out ಮಾಡ್ತಾ ಇದ್ದೀನಿ. R2, R3. So how many branches it is getting divided? Correct? So suppose if I take it here, this junction, again, how many branches? 1, 2, 3. That's why if I just take it as point number A and B, if I start from A, see here, start from A and just go to B. 1, 2, 3, this is the direction. Here in the second branch, this is the direction. Third, this is the direction. At this you can see all three are getting combined together once again and they are coming back. Correct? They are coming back to the same this thing. See here, starting from A, it is joining at this point and coming to an B. This is what you have to follow in any of the series and parallel branches system. Now if I wanted to find out equivalent resistance between A and B, I am starting from A, correct? Starting from A, so at junction 1, it's getting divided into 2. Which are those two? R4 and R5. Correct? So it says that R4 and R5 are parallel with each other. Correct? Next, at junction 2, matte I have to follow only from A to B, circular agi. So B hatra bandaga, to point 2 hatra bandaga, junction 2, again it is getting divided into 2. Correct? Okay? And now this is R1. You can see that R1 and R2 are in series. Same bhavagutala. Is there any branch division here? No. So that means you can see that the current flowing through R1 and R2 is same. Therefore, I consider R1 and R2 are in series. Got it this? Start from A point A and then slowly move on. You can just observe R6, the current I flows. Let me say it is I. It's getting divided into two branches at junction 1. So where the two branches, where we have a resistor R4 in one branch, R5 in another branch. That means R4 and R5 are in parallel. Next, coming to junction 2, this current you can observe. And where does this current flows? It joins here. ಮತ್ತೆಲ್ಲ ಬೀಗ ಹೋಗ್ಬೇಕೆಲ್ಲ. Correct? At junction 2, you can observe that it again branches out into 2. So one branch we have R2 in series with R1. Another branch I have R3. Again, this current will move on to this, correct? And this current will move on to this junction. And combined together, it will move across this junction. This current and this current join together and moves like this. Now let me put an numbers for this. This is I said. Let me take it as I1. This as I2. Correct? Okay? Source is not there. I am just taking it for a combination of resistors to find out whether it's connected in series or not. So I1, I2 ಆದರೆ I2 ಒಂದು ಇಲ್ಲಿ ಮತ್ತೆ ಡಿವೈಡ್ ಆಯ್ತಲ್ವಾ. Let me take this as I3 and this as I4. Same current flows here, correct? I4. Correct? Now at this junction, which are the current that is joining? I3 plus I4. Okay. This is I3 and I4 joins together and flowing here. And what is the current coming here? I1. Illi? No, 1 minute. Here, yeah, I2 is getting. Now here at this point, I1 plus I3 plus I4. Now you just connect here. What is this? I3 plus I4 is equal to I2. Correct? So now at this point, again I can say I1 plus I2. Correct? Now what is I1 plus I2 equals to here? I. This I is getting divided into I1, I2. Now I1 plus I2 is coming back to your. So again what is I equals to? I1 plus I2. Correct? Whatever current the source is giving, it will just flow and come back to same current will come back. Nowhere it you can see that it will be stopped or it is somewhere lost or something like that. Current what you are just making it flow at one point, it comes back to an other terminal. Suppose if I connect an source here, so this is the current flow I. So it gets divided like this and once again comes back to this negative terminal. That is the meaning. Now tell me what is the equivalent resistance of this? ಹೆಂಗ್ ಹಾಕೊಳ್ತೀರಾ ಇದನ್ನ ಈಗ? You need to find out, isn't it? First what you will do? Same way here we already done. What is that? R1 plus R2. Correct? Series allide. So I'll just put it like this. Erdanno. Let me reduce it as much as possible. So let me take this as R3 as it is, R4 as it is. No, R3 as it is. And what is this combination? R4 parallel with R5. Parallel combination ಏನು ಮಾಡ್ತೀರಾ? R4 R5 divided by R4 plus R5. R4 plus R5. One resistor ಆಯ್ತಾ? So now this is already I just reduced it and I have an R6 here. Correct? ನಾನೀಗ ರೆಡ್ಯೂಸ್ ಮಾಡಾಯ್ತು. ಪ್ಯಾರಲಲ್ ಬ್ರಾಂಚ್ನ ತೆಗೆದು ರೆಡ್ಯೂಸ್ ಮಾಡಿದೆ ಫಸ್ಟ್ ಸ್ಟೆಪ್. ಇನ್ನು ಈಕ್ವಲೆಂಟ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಹೌ ಟು ಫೈಂಡ್ ಔಟ್? How to find out now? These two will get added up now. R4 R5 divided by R4 plus R5 plus R6 ಆಯ್ತು. Next, these two will be in parallel. R1 parallel with, this is R3 ಅಲ್ಲ, R3 ಇದು. Correct? Okay? R3 and R1 plus R2 are in parallel. This is parallel ಮಾಡಿ combination. Reduce it now. So what is the equivalent value? R1 R2 into R3 divided by R1 plus R2 plus R3. Correct? That is the equivalent resistors. Now you get all are in series. Total ಏನಾಗುತ್ತೆ ಈಗ? I'll still reduce. So this will become R3 divided by R1 plus R2 plus R3. Correct? So this plus this now it is equivalent resistance of yours. We'll take one example. I'll give one problem. So you can solve the same way. Values ಕೊಡ್ತೀನಿ ನಾನೀಗ. You just solve it and tell me. Okay. Find the equivalent value. Find the equivalent value between A and B across the terminals AB. Junctions and all you have to put the directions, you understand, and then find which are all in series and which are all in parallel. See, this is how actually this is very important. If you learn this technique, you can solve any of the network path, this one, circuits. So 3K here, I'll write down 3K here directly, and this 5K I'll just retain as it is. I'm just reducing, and the simplest step I'll reduce ಮಾಡ್ತಾ ಇದೀನಿ. 10K here as it is, okay, 20K, and here it is 15K. Correct? These two are the branches now between or equivalent between these two, A and B. Second step is, I can just see here, starting from A, these two are two branches. Correct? Okay, these two are two branches, and at this point we have two branches. First ನಾನೇನು ಮಾಡ್ತೀನಿ, simplest way ನಿಮಗೆ ಅರ್ಥ ಆಗಲಿ ಅಂತ, I'll just reducing first 3K as it is, ಯಾವಾಗಲೂ ಬ್ಯಾಕ್ ಸೈಡ್ ಇಂದಾನೆ ಬರಬೇಕು. Next 5K also I'll take it as it is, and these two I'll reduce it into an parallel branch, that is 10K and 20K. So what is the equivalent resistance? 200K by 30K. So 20 by 3. And I have in series 15K. Correct? This is A and this is B. Okay? Now these two are in series. Can I add it up? So still if I reduce, what will I get? 3K, LA, 5K. So this 20 by 3K and 15K add up ಮಾಡಿ. Add up and tell me. 6K, correct? A and B. Okay? Now I can just see that at this point these two are parallel. ಯಾವ್ದು 3K and 5K are in parallel. So what I'll do, so I'll just reduce this into parallel branch into 3 into 5 divided by 3 plus 5. And we have in series 21.6. This is A and this is B. Correct? Okay. Now what is the value? 15 divided by 8. So this will be 1.8. 1.8 plus 21.6K. This is A and this is B. Now it's very easy. 21.6 plus 1.8, 28 point. Oh, no.
22
Yeah, 22 point. ಅಲ್ಲಪ್ಪ 20, yeah, 23 point ಎಷ್ಟು? 4. 4, 5 ಎಲ್ಲಿ ಬರುತ್ತೆ? 23.4 ಬರುತ್ತೆ. So this is now between A and B, correct? What is between A and B now? 23.4 kilo ohms. Did you understand this? ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ರಿಗೂ? Is it okay? Okay, next ಇನ್ನೊಂದು ಪ್ರಾಬ್ಲಮ್ ಕೊಡ್ತೀನಿ ನಿಮಗೆ. Let me see how many of you will do the correct way. You need to solve there itself. Wherever you are there, you solve there itself. Find the equivalent resistance between terminals A and B. 5 plus 3. So we just mentioned here. In this branch, 5.5K and also 2.5K, totally series 7.5K, and we have 1K here, and then we have 4K in series. Now you just see here at this junction 1, again 2 branches, and this junction 2 branches, right? So what we'll do, first we'll just find out what is the equivalent of 7.5 and 1K.
0.2.
Yes, that in series with 4K. 3.5K, 7.5K, as it is I'll keep, and these two parallel combination 7.5 and 1K, how much you'll get? 0. And one more thing you need to observe here. See, when we connect very high resistance and low resistance, always it is lower than the low resistance, total equivalent value. 2 parallel resistor only, you can just check it. 1K, 100K, if I just connect in parallel, 1 into 100 divided by 1 plus 100, 100 divided by 101, it is less than 1. Correct? So that means you can always observe that these are all the tips actually. Whenever you connect very high and very low resistances, you can observe that always equivalent resistance is less than the low resistance. You'll get it. Okay? So where we use it, we can observe. One the short martini, one the resistor connect martini. Okay? And another parallel branch is there, let me say. Where does the current flow? Current always take the path of a low resistance. Howda? Always it takes the path of a low resistance. So when 2 branches are in parallel, whichever branch has got a low resistance, that path only the current will take place. That is also one of the tips where you should know when you are connecting the resistance. And 0.88, where 0.88 is less than your 1K. In parallel combination, 7.5K, 1K, 1K is the lowest, smallest resistor. So equivalent, if I find it, it is less than 1K always. And then we have an 4K here, correct? This is point A and B. Now, these two are in series, which are 4K and 0.88 are in series. First you just solve that 4.8K, 88K, and this again you can observe that these two are in parallel. 3.5K and 7.5K are in parallel. So what is the equivalent resistor? 2.38K, and here these two are in series, 4.88K. So this is actual resistance between A and B. So which is equivalent to 2.38 plus 4.88, 7.27. Okay. So this is the equivalent. How did you get 7? Huh? So this is how you have to get it. Now what we do, Andre, we'll take the resistors. I'll just give you the resistors, few resistors. I'll just mention the combinations with R1, R2 like that. You just connect it on the breadboard. Take the values of that. First theoretically you prove it. How much is the equivalent value? Then take practically, you just check it with the multimeter and see that what is the equivalent resistance. Correct? That is how we check it, right? Theoretically what I am finding, practically what I am finding, that should match. But it will be little bit lesser or more. Why? Tolerance will be there. Exact values will not be there, right? So that is how. So we'll do that one exercise and we'll move on to an Kirchhoff current and voltage law. Can note down this circuit. Little bit changes I have done and I given. Okay. So you need to find out the equivalent resistance. First you take the resistors. Okay. See the color coding and write down the values as per the color coding. So we are completing color coding exercise, resistors in series and parallel in one of the experiment. That's all. One exercise we are completing everything. Between A and B, potential has been applied between A and B. Current direction is starting from A anta imagine ಮಾಡ್ಕೊಳ್ಳಿ. So now this current, let me take it as I. Let me take this current as I. Now this current at junction 1, idu junction 1 anta ತೋಳೋಣ. At junction 1 it is getting divided into two branches. ಹೌದಾ? Let me take this as I1 and this as I2. Again I2, so anyway I1 flows like this through R5 ಬಂದು B reach ಆಗುತ್ತೆ. ಈ ಜಂಕ್ಷನ್ ಹತ್ರ ಎಲ್ಲ ಜಾಯಿನ್ ಆಗಿ ವಾಟ್ ಆರ್ ದ ಅದರ್ ಕರೆಂಟ್ ಜೊತೆ ಬಿಗೆ ಹೋಗುತ್ತೆ. I2 at this point again, I2 passes through R3 and at this junction, junction 2 ಹತ್ರ ಮತ್ತೆ it divides into two branches. Let I2 divides into an I3 and I4 ಅಂತ ತಗೋತೀನಿ. Okay? It divides into two currents, I3 and I4. Now I2 is equal to I3 plus I4, correct? Similarly, I is equal to I1 plus I2. ಹೌದಾ? And branch of current I2 is equal to I3 plus I4. Correct? Now according to that, ಇಲ್ಲಿ ಯಾವುದು ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ? I4. ಇಲ್ಲಿ ಯಾವುದು ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ? I3. ಈ ಜಂಕ್ಷನ್ ಹತ್ರ ಯಾವ ಕರೆಂಟ್ಸ್ ಬರ್ತಾ ಇದೆ, ರೀಚ್ ಆಗ್ತಿದೆ? I3 plus I4. Because both are towards, so I'll take it as an addition. Correct? And what is the current flowing here? I2 ಅಥವಾ I3 plus I4. Correct? Is it okay? ಅಂದ್ರೆ ಏನರ್ಥ? Now I3 plus I4 is flowing through an R4 andre these two branches are parallel and in series with R4 anta. Correct? Correct? In series with R4 anta. Correct? Then it is series with R3. Correct? So ಅದಕ್ಕೆ ನೀವು ಏನು ಮಾಡಬೇಕು, ಫಸ್ಟ್ ಈ ಬ್ರಾಂಚ್ ಹತ್ರ dividing into 2 and here it is dividing into 2. So first ಇಲ್ಲಿಂದ ಮಾಡ್ಕೊಂಡು ಬನ್ನಿ, ಇವೆರಡು ಪ್ಯಾರಲಲ್. ಕರೆಕ್ಟಾ? ಲೆಟ್ ಇಟ್ ಬಿ ದೇರ್. ಸೊ ದೀಸ್ ಟು ಆರ್ ಪ್ಯಾರಲಲ್ ಅಂಡ್ ಸೀರೀಸ್ ವಿತ್ ದಿಸ್. ಫಸ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಅಂದರೆ ಏನರ್ಥ? ಸೊ ಬ್ಯಾಕ್ ಸೈಡಿಂದ ಬಂದರೆ ನಾನು R1 and R2 ಆರ್ ಇನ್ ಪ್ಯಾರಲಲ್ ವಿತ್ ಈಚ್ ಅದರ್. ಸೊ ಪ್ಯಾರಲಲ್ ಕಾಂಬಿನೇಷನ್ ಏನಾಗತ್ತೆ? R1 ಪ್ಯಾರಲಲ್ ವಿತ್ R2, ಇದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ, ಪ್ಲಸ್ R4. ಕರೆಕ್ಟಾ? ಅಂಡ್ ಬ್ಯಾಕ್ ಸೈಡ್ ಮತ್ತೆ ಪ್ಲಸ್ ಏನಾಗುತ್ತೆ? ದೀಸ್ ಟು ಆರ್ ಇನ್ ಪ್ಯಾರಲಲ್, ರೈಟ್? ದೀಸ್ ಟು ಆರ್ ಇನ್ ಪ್ಯಾರಲಲ್. ಸೊ ಪ್ಯಾರಲಲ್ ಆದಾಗ ಮತ್ತೆ ಏನ್ ಮಾಡ್ತೀರಾ? R3 and R5 are in parallel. So that is and this is in series with this combination. Correct? Okay? This is in series with this two combination. So adadmele enagatte? R6. This is your equivalent resistance. Find out madi.